So today we'll go into chapter 8, which is involving friction. So yeah, this is characteristic of dry friction and problems involving dry friction. So for the objectives, towards the end of the lecture, you should be able to understand what is the characteristic of dry friction and then know how to solve using Fribo diagram and also equation of equilibrium. Right. Okay. In terms of application, I think this is one of the most common, but I think it's many of us should know this one on the braking of the bicycle tire. I think this one as an example. Also, if you try to pull the refrigerator that this guy tried to do, you will have friction there, right? Now, so what is friction? Friction is defined as a force of resistance acting on a body which prevents or resists the slipping of a body relative to a second body. So basically, friction is the thing that happens between two contacting bodies, right? Meaning that, of course, the next body can be the ground, the floor, etc. Normally we deal with that situation. So when movement relative to one another is happening, you'll have friction there. Right? So basically that's I think what we understand anyway. Right, so experiments have shown that frictional force act tangent or parallel to the contacting surface in a direction opposing the relative motion or tendency for motion. Right, so if on this table we have something moving, so the friction will be along the surface of the table. Basically, that is what is the implication there. Right? It's along the surface of between the body. Right. Now, so we will go into some concept of what is happening when you have the interaction there. So let's consider this. What if you have something like a box there on a surface? So if you draw a free body diagram, it will be just isolated like that. And in this case, let's say if I push it in this way, right, it's a force P. Of course, the box will have its own weight, and of course there will be normal surface, normal force countering the weight so that it will stay there. It doesn't go down, right, because of the surface. And when you push or when you apply the force, then friction will be developed in the opposite direction. Okay, I think so much we understand. Now, for the object to be in static, there are several things that have to be satisfied, which is summation of force should be equal to 0 and summation of moment should be also equal to 0. Correct? So if any of this is not 0, can it be static? No. Alright. And F, you have also X on and Y. Now, before we apply the force, friction will not be there, right? Meaning if we want to draw P and F, meaning P is the applied force, F the friction. When P is 0, friction will be 0. Right? And in that condition, there's only two forces existing. The normal reaction will counter the weight. So in that case, force equal to 0 because this counter this one, this is still 0. Moment is 0 because Now when we apply the force, for example, we apply 1 Newton, what will the friction be to make it static? So it will be 1 Newton, right? If it's 2 Newton, 2 Newton, etc. Right? So we have a direct relationship like that, right? Where it will always counter the load there so that this remain 0. Right? However, in reality, this will have its maximum value it can go, and that depends on the surface. For example, if you have a very rough surface, then the maximum can be very high. That's why if you want to push some object on a rough surface, you have to apply very high force before you can overcome the maximum friction. If you have a very slippery surface, oily marble floor for example, then just a small surface, it already is maximum, and then it cannot resist anymore. It will slide, right? So that's the maximum. So if you push, meaning if the maximum is 2, for example, when it's 2, it's reached there. If this go above, this cannot go above because it's already maximum. That is where this will be more than that one. You will have movement that direction, right? And in that case, because this will be the end of static, and this is already dynamic, right? So that one you will have to learn next semester, right? Kalau suka sangat ni, datang balik lah semester. But yeah, so the F max depend on the type of the surface, but that's the reality, right? Meaning that this can only go up to a certain maximum value depend on the surface that we have. So do you understand that one? Meaning that friction will vary depend on this one. Now, again, the concept is what? The concept is it will only be static if both are 0. When we apply this one will have the same value. This one will counter this one. So summation of F is always 0, right? What about summation of moment? Is it 0? In this condition, for example, this is 2 Newton, this is 2 Newton, this whatever, this is the same value there, right? Is it 0 moment? What is this one? This become couple, right? Same value. This couple will cause which rotation? Right? So is this 0? If not 0, is it static? But if you push and it still remains 0, okay, that's two different. If this actually you have a value, then that's why you push and it topple. It topple that way, right? But before it topple, meaning that this is still 0, meaning that something is providing counter moment, so that is still 0. Where does this come from? Meaning, because if you put something before it topple, for sure something is countering that moment, otherwise it already topple, right? How, where? Wait, what about wait? Kenapa kan wait? Wait, kenapa wait? Oh wait, oh tunggu. I thought you were saying wait, no, wait. Okay, so confusing. Okay. So how many minutes should I wait? So gravity. Friction. This friction is what causing this one, right? You cannot say this one also provide this one, because this is what causing the clockwise moment. Siapa push? Ada orang lain tak push? Dia toyo dah nak orang tolak. Now, what happened is actually this one move. Normal reaction. You cannot see this physically, but the position of this normal reaction move, so that this will cause this moment. Meaning originally it's at the center because it counter this one and it's just one line. But when you push, that normal actually goes and it shifts. So that this will cause whatever necessary moment to counter this one. The bigger this one goes, because this value is the same. The weight is just the weight, and is exactly summation of Fy. But the position will have to go to counter how much moment there. Alright. Now, so we have discussed one possibility is that when it reaches maximum and you further increase force, it can no longer resist the movement, the friction is maximum already, then it will move, right? That happens if this is still within this range. Now, what happens if we are still in the middle here, meaning F is no longer, is still not F max, it's still here, but N is already at the edge here. Because N move until edge. It cannot no longer move because N has to be at the contacting surface. So that's the maximum position it can get. So if you increase this further, F can still increase if it's still in the middle here. N can no longer move. Then that is where it will taper, because this moment will not be able to increase to counter this moment that keep increasing because of this value. Right? So the phenomenon is that in such a way that there are two possibilities that can happen. Which is why this chapter is normally more interesting than the previous chapter, because there are, if this happens, something is different, this happens, something is different, which is making sometimes the answer can be longer for this kind of question. Okay, first on terms of the phenomena, do you understand what's going on and why it's going on? So that is why if you have object like this, right? Normally it's very hard to topple over, right? You can, because why? Because N have a long way to go, and normally before it reaches the end, F is already F max. That's why it tends to move first. For this kind of object, normally N have a very short way to move, and it is the end first before F reach F max. So that's why we topple, right? So that's the what explains what normally we can experience anyway, right? So how to solve? That's the interesting part, because when you want to solve, for example, the question says what is the force that you can apply before it moves. There's two movements is possible. One is slipping, one is tipping. Right? Slip and tip. Right? Slip. You understand? You know slip, right? You can slip. It's slip. S-L-I-P, bukan S-L-E-P. Alright, so that's the physical phenomena, which means some of the question we have some conditional that you have to apply to be able to solve, right? So to study statistic, okay, this is basically just to explain this graph. Hopefully you understand this one, right? We are involved in here from 0 until F max. This one is motion, and in terms of the value, it can be determined by this one. This is F max equal to USN. F max static, right? And then next semester you will have kinetic, where this part here, the remaining part here, you have another view there. Okay, so we will not go into this one. This is just information for you to be eager to go for dynamic, so on. Right? Because static is boring, right? It's stationary, yeah. Okay. Now, it is important to note that friction may be less than maximum friction force. So just because the object is not moving, do not assume the friction force is at maximum USN. Okay? Understand? This is, what is this equation? This equation is F max equal to F US N. Right? If F is still here, it's still less than USN. So do not just because friction, you know this equation, you just straightaway use, because it can be less than that one. So you have to understand the question is in which region. Right? So there are several things that, have we go to the word yet? Okay. I think there's a word here. Okay. There's one word here, impending motion. So if you see this word, impending, motion meaning that the moment just before motion happen, meaning that the maximum static. Impending motion meaning just a tiny bit of force, it will already dynamic, it will move, right? So if you see impending motion, then it is μSN. If there's a different word that is described, for example, it says, what is the maximum force that you can apply without moving the object? Do you understand that? meaning the maximum force without moving, meaning the maximum before, just a bit after that, it will already move. Meaning that is the case of mu Sn, etc. If it doesn't say anything like that, then it can be less, meaning before Fmax. Okay. Alright. Determining mu S experimentally. Okay, this is, inshallah this will not be in your exam. This is just for you, for those who are interested to do experiment. For example, after learning, oh, I want, what is the friction between my laptop? So if you, right? So you can go to the side. Basically, this is how it derived. I'm skipping this one until you get this equation here. Basically, it relates mu S with theta. So when you get theta, you can calculate mu S. So basically, what you do is, if you have a surface, an object on the surface, you increase the theta until the point where it starts to slip. You take note of the theta, you calculate, you get mu S. So you can go back and you can leave things and say, oh, okay, this is mu S, right? So that is things that I don't know, minority of you might be interested in. Okay. Now we go into the problem solving. So in terms of the steps are as always: draw free body diagram and apply equation of equilibrium. Just that the difference is how to draw the free body and how to include friction in the free body diagram. That's the new thing here, right? So again, it says do not assume mu Sn unless in bending motion. So there's a lot of reminder here because that tend to be common mistake that you do, right? Because you memorize the equation, you want to just plug in there. Right? Now, make sure to show the friction force in the correct direction. Okay, here's one important thing. When we learn about support reaction before, for example, if you have a pin, right? If I take it out, so you can draw it like this or like that. These are just assumptions, and in the end you get the correct answer anyway. But for friction, you cannot assume, because if you put it in the wrong way, the calculation will be totally different. So you have to understand where the direction is. This one is assumption, this one is not. You have to show the correct one, because if you put it like this, it's totally different. The calculation, you will notice that one. So, and it says it is always opposing the motion or impending motion. Do you understand it? Meaning the friction direction is opposite of the direction of motion or impending motion. Motion meaning if it's already moving, is of course. But impending motion, because if we are static, the object is not moving. Meaning just before it moves, what is the movement tendency? If it moves that way, friction is countering. Now, just to see whether you understand, if we have the box like this, we push it this way, right? If we draw the free body diagram, which direction will the friction be? Be like this, right? Everyone agree? Easy to understand. If it's like this, P is like this, right? If you draw the free body diagram, friction will be in which direction? Right, downward or up? Like this. Everyone agree? Oh, up, something up. No. Kami macam ada sekat up. Maka ini up macam ni. Down. Now, so everyone agree? Macam ada yang tak suka makan malam. Okay. Actually, this is where you cannot just depend on the diagram. Because why? Because the object has its own weight, right? If, for example, the weight is not that big, when you want to push it, the object tend to move upwards. It's about to move upward, then friction is downward. If, for example, your force here is low and the weight is high, in this case, it tends to go down. Friction will go up. So how to know that? You have to read the question. Just the diagram will not confirm anything. You have to read what is happening actually. So I think in the one of the previous semester there are one diagram with 3 different questions, where each time the friction change direction. So you have to read what is happening. Because if question says something like this, what is the maximum force to prevent it from sliding down? Okay, what is the direction of friction? Do you understand? I repeat the statement. What is the maximum force to prevent? What is the maximum force? No. What is the minimum force to prevent it from sliding down? Because any more than that is also not going down. But what is the minimum force? Okay. What's the direction of friction when you want to draw a free body diagram? Upward. Because the tendency is going down, right? So want to know what is the force to further support so that it not go down. That's the meaning of the question. Right? It's different if the question says what's the maximum force before it goes up, before the balls move up. Then the motion is upward, the friction is downward. Right? So that's how you have to interpret the question. Because it's not about the force, it's about the motion. So do not mistake the two, because even though force upward, maybe the motion is downward. Alright. Impending tipping and slipping. So this is related to the two possibilities that we have talked about just now. Okay, let me put it this way. If we have a block like this on the ground and we apply a force there. Obviously, when we do example to explain the concept, we always have a flat and force a flat like this, right? Because it's easy to understand. In the question, it can be have an angle, etc. Then it will be more complicated. But now it's just first to understand the concept. When you draw the free body diagram, now you have to assume, because the free body diagram will be different for if you assume. Okay, this is if. Okay. Now there is several different way of question that it can be given. For example, what is friction? That is one question where if you say what is the friction, you just consider there's a P, there's a friction, you calculate the friction, and it just counts. This should be the same, for example, in this case. But the question will be different is, what is the maximum force P that can be applied without causing movement? You understand that? Or similarly, what is the force P that will cause impending motion? Okay. Now, in this case, actually the motion that can happen is either tip or slip. We have discussed it just now, right? So without, because why is it different? Because for tipping, N is here. For slipping, N is, meaning the diagram is different and the calculation is different. So if you assume slip first, and we assume tip first, the free body diagram will be different. If you assume slip first, okay, P is here, weight is same, and of course it will have some measure, but if you assume slip first, it is still not reaching the end. Right? So you have an unknown distance there, and then this is the normal, and then you have friction there, right? But what is the assumption? The assumption it will be slip first. So if the question says about impending motion or maximum force before movement, so this equal to F max or equal to mu s n, right? How many unknown do you have? Okay, normally if the question is given like this is given and mu is given also. So you have 1, 2, 3, and this is the same as this one, right? Then you can solve. Now, if you do not have any of this assumption, F you do not know equal to mu s n, so F is another unknown. You will have more than 3 actually. Right? So that's why you have to assume. This is one assumption. Oh. And then the next assumption, okay, you understand this assumption? Assumption is before n reach the edge, friction already reached maximum. If you assume tip first, what is the assumption? N is already at the end here. F. Does M equal to mu s n? No, we assume it's not yet mu s n, right? So in this case, what we assume is, because this is given, and we assume n is at the edge there. So we will have 1, 2, 3 unknown. Now, you have to assume so that you can draw the free body diagram. Without assumption, you cannot draw free body diagram. Without free body diagram, you cannot even calculate anything, right? So even if you assume, you draw, you determine the answer. How to know if the assumption is correct or not? Because you cannot just assume you get the answer, this is correct. Because the assumption can be right, can be wrong. If this is wrong, this is right. If this is wrong, this is right, right? So how to know your assumption is correct or not? So you have to check the assumption. Okay, what's the fundamental assumption here? This first, before this reach the end. So basically you check whether it's actually before. So you check x. If x is still within here, then it's correct. If x is already there, then it's wrong. Right? Because you have to check the value. It will be some value. Is it still within this range or is already exceed? If you exceed, meaning the assumption is already wrong here because we assume n is still within here. This one, what do you assume? And what do you need to check? We assume this is still less than maximum, right? So what you do is you check for f. If it's still less than f max, which is mu s n, okay, if it has already exceed f max, then it's wrong. F max is mu s n, so you check with mu s n. So do you understand the idea? So there are many possibilities that can happen in exam if you have a question like this. One is if the answer is this one, this case. If you assume this one, you will check, assumption is wrong, I have to repeat my calculation. So you go here and then you get the answer. If your friend assume this one correct, then it stop there. That's correct already. Meaning the length vary with your rezeki. Okay, but because that is a possibility. Normally, because I'm not sure when was the last time this thing come in the exam. When it comes, the mark is distributed half here and half there, generally speaking. So if the answer is here, for example, you assume this one, and then you calculate, you check, that's correct. Half of the marks here already embedded in the checking. Because when you do checking, you actually prove that you do not need to repeat. Your assumption is correct. But even, okay, some students, if you assume correctly, luckily they assume correctly, they calculate, they get the correct answer, but they never check. You have not proven that that's right, so you will lose the half the mark there. That's how it's calculated. Right? Do you understand that? Now, the one because this actually happens to some students. One issue is, for example, this is the correct one. They assume this one. They do the correction and calculation. They did a mistake. They say, assumption correct. They stop there. So they lose half of the mark there, and of course they do not get the right answer also. So that's the worst case scenario lah. So that's why if you have the time, and normally we do give the time for both because it's not fair to give time only for this one, not fair for those who assume the other one, right? So you just do both. That's one if you are not sure about the one. So that if you check this is correct, this is not, or otherwise, then you know for sure. Because for whatever reason, if you suddenly say, I check this one, this is correct. I check this one is also correct, then something is wrong. Because that cannot be the case. If you check this is wrong, then you are wrong also. Meaning something wrong with your calculation. Right? So that are the possibilities. Now, for those who would find this too complicated, benda lah, banyak sangat benda ni. And you still want to answer, you tak nak repeat. One way is, basically you consider this case, you get this P, right? If the question is what is the maximum P, etc. P something. You calculate this one P, the smaller one happen first. You understand that? Meaning for it to slip, the value is 500 for example. For it to tip, the value is 400. For sure when you reach 400, this already happened before this happened. So that's one way where if you find the checking quite tricky. You just calculate both and you just compare. If you do this, you don't need to check this one, because it's just whichever is smaller, that is the correct answer lah. So that's also a method. So whichever method that suits you the best, you can opt for that one, as long as it's clear what's going on lah in your exam, especially when you talk about the exam. So the examiner have to be able to follow what's going on, right? And for that, you have to have a proper flow. You do not, mean in your paper, you cannot just write here and then you here and here, because the way we evaluate, we assume the flow is like this. We cannot understand, you start here and then you continue here. That doesn't make sense, right? Because some of you have that tendency, you meaning the flow is very random, right? So we cannot follow what's going on. So for the exam, especially for this one, because the flow is important. And if you assume something and then the assumption is wrong, do not, when we say repeat, it doesn't mean you erase, because that part of the mark also. You understand that? Meaning just you have to add another half to get the full. Right? So you understand that those are. This is why this is the chapter where we have if-else case, unlike any other chapter before, right? So as a summary, basically it will be what we have said here is summarized here also. We have two assumption that you can make. If you differentiate first, this is here, f should be f max, right? And then you calculate, you check for x. Why this b over 2? Because this is b over 2, right? What I said earlier is just, okay, it should be within this one. For example, if suddenly you get x here, you get x negative, for example, what should you know? For sure, you make it positive. Be positive. No. It's not possible. Because, why? Because from, especially if this one, P and F already clockwise, right? If N to the left, then it's another clockwise. That's not possible. It's not possible to be static. So you are fundamentally, it should be here. So if you got negative and you're still confident about the answer, then we say, you memang tak faham, jumpa lagi lah, right. But, okay, for your sim tipping, again here, and then you check for this one. Right, this is the normal checking method, right? So, yeah. Okay, I just mentioned several things that happen to the student. Now, when you cannot simply just draw a free body diagram in this particular case without specifying what is your assumption. Because, for example, if one student say, I assume slip first, but they draw this one, then that's from the beginning, that's wrong. That doesn't match. So if you do not say anything, you straight draw, kita akan sangka buruk lah, you tak faham lah tu. So make sure you write, so dia zone lebih sikit masa exam ni. Right, so, yeah. Alright, concept quiz. If you have weight here, white base. Okay, sometimes they have some statement like this. White base. What is the significance? Why is it important? Yeah, if it says white base, then you do not need to consider tipping. Because normally white base, it doesn't have that possibility because n is so some clue is sometimes given in some question where this question for sure no tipping, for example, right? It's pulled by force P and mu s is okay. Which orientation require which require least force? Okay, between this force, which will require the minimum the least force? Okay, if I put a different question, if I want to pull a heavy box like this, if I pull here, or pull here, let's say P1, P2, P3, right? Which one is the best option? P1, P3, P1, P2. Kena berubah ni. Why? Why P1? S. Now, what? Okay, the best about what? Now, when we say which one require the least force, meaning you do not need to spend too much energy. Which one? Kenapa P2? Kenapa P1? P3 pula. Tak pendirian ni. Now, if you do summation of fx equal to 0, right? For P2, what will happen? P2 equal to F, right? In the end. If for P1, we have theta here. P1 cos theta equal to F, right? In the end. So, if friction maximum is the same, which one will be higher, which one will be lower? P1 or P2? Which one will be lower? P1 lower? P2 lower? Which one will be higher? Now, to get the same answer, this should be bigger, right? Because this will make it small. Cos theta will always 0 point something, right? So to get the same, this one will be small, and this one will be larger, right? So if you actually use this one, you are wasting your energy lah. Because half of your energy is part of your energy is this component. Part of energy is this component. This component does not have anything to do with overcoming the friction. It's more of lifting this thing, right? So if you just want to slide, then you are wasting this amount of energy lah. Right. So this kind of question, actually it doesn't have that much thing to do with friction. It's just on if you understand the equation of equilibrium and free body diagram implication. Anyway, but of course we are talking about static. Now, some of us feel it's beneficial to have some angle upwards because of when we go for dynamic, there's something else. Right? For example, if dia terangkat sikit, dia kurang friction. So that's dynamic later on lah. For static, just about to move. Horizontal is. Alright. This is a ladder. Jangan tanya siapa lukis macam ni. Okay, so please indicate the direction of friction at B. That is one. Which direction will it be? If you don't want to draw the friction. This one. Why? Why not this one? Yeah, in this case, the only possibility is it want to slide down, right? Because it doesn't have any force. So it wants to slide down, then force is in this direction. Okay, fine. Alright, I think, okay, we have an example here. Okay, automobile has a mass of 2,000 kilogram and US is 0.3. Find the smallest magnitude of F required to move the car if the back brakes are locked and the front wheels are free to roll. Do you understand the question? Okay, wait. Do you understand the black one here? Find the smallest magnitude of F required to move the car. What do you understand by that? What? F minimum. Minimum apa? F maximum. Faham tak ni? What is the smallest volume of magnitude of force required to move the car? Meaning what? Kau tak faham? What's the minimum force required to move the car? Ada tengok kenapa minimum maximum? Okay, what is the meaning is that because minimum force to require the force car, meaning that any force above that obviously will move also. So what's the minimum force to move the car? Right? Meaning what? Meaning is that the maximum static, right? Just before it go to dynamic. You understand that? Okay. So in that case, it is a case of F equal to mu S N. This is F max condition, right? Okay, so that's the first one. What about this one? Back brakes locked and front wheels free to roll. Mana ni? What's the implication? Okay, tu titik kan. Okay, so if you draw the free body diagram, okay, let's draw the free body diagram first. Mana? Tu. Saya kecil sangat tayar dah. Mana depan ni? Abaikan model kereta ni. Boom. Okay, F. And then G, so you have weight there also. Okay. Oh. Now, so what is the implication of this? Back brakes are locked and front wheels are free to roll. Friction. So what about the friction? Friction at the back. Right or left? To the right. Friction. Here? No friction. Why not? Free to roll, right? Faham ni maksudnya? Maknanya free lah, tak payah bayar kan? Right. Okay, it means basically the wheel can roll, right? So if there's possible movement, so it can roll, meaning it doesn't have the friction. Lock meaning that the tire will be dragged in that way, right? So there's only friction there. Faham? For those yang tak pernah jumpa kereta semua, kena faham lah. And it's not only car, because I think if you just flip through, just like in previous chapter where we have different support action, right? General bearing or whatever. So if you have never seen mechanism like that, it can be quite difficult to understand. Anyway, what about, is this complete or something missing? Normal. Where? At A or B or both? Normal. Or somewhere else, at tengah? Depan dia? Somewhere here. Somewhere apa? Dia macam somewhere. Betul ke ni? Itu kita. Kelak pula. Faham tak ni? When do we have normal reaction? Counter. Kita bayar kan? Counter? Okay. The normal counter way. But when do we have? It is basically at when you have contact, right? So here, where is the point of contact? Right? So make sure you understand. There's a different where you have a long contact. This is where N can be along this way. This direction, right? When you have a point contact like this, it's just there. Just like a roller, rocker, etc. It's just there. It cannot go anywhere because the point of contact is 1 point. Right? Okay? So make sure you understand this one. And I think there's in the book where one of these disappear. Can you guess when suddenly you don't have normal? free flow. When the contact disappear, right? Meaning for example, badang dulu ni, dia angkat. Badang tu kenal? Ham lah ham. When it's all about the lift, right? So there's no normal force there, right? So in this case, there's 2 point counterpoint. Okay, right? So when you have question like this, there's no tipping, etc. Because there's no issue of that thing, right? Alright. How many unknown here? This weight is given. Weight is 2009.81. This is known. How many unknown? Okay. One thing, we cannot use F, unfortunately, because this is already F. So you have to use FB lah. Because it has to be different. Otherwise, when you calculate, it will F and you calculate the same thing. It should not be the same thing. Okay. How many unknown? Are we missing something here? If you calculate 1, 2, 3, 4, which is you cannot solve, right? This one, what is this? Mu S and B, right? In this case. So how many unknown? Because mu S is given, right? So it's actually 0.3 and B, right? So how many unknown? 1, 2, 3, and the same, right? Can we calculate? We should be able. We have 3 unknown. Okay, what's your strategy? What should be equation that you want to use first? Summation of fx. Now, okay. Will be having simultaneous equation? If you do summation of fx equal to 0, what is the unknown there? You have F, but you don't have ND, right? Correct? If you do summation of Fy, what do you have? F you have, and E you have, and B you have, right? If you do, okay, moment. Okay, moment because you have the option, moment about which point, right? What point do you want to have? Mana? B, C, mana C? Oh sini. Cepat sangat ni. B. If you want to put C, okay, but this one because you have this distance also, right? This one, this small, because A and B is on the ground, right? C is here, then you memang cari penyakit lah. Not advisable. So if you take moment about point B, how many unknown do you have? Yeah, betul. This one you have F, right? Do you have ND? And it also, right? Can you solve? You can, but it's become 3 equation, 3 unknown, right? So, it will be a bit long. Is there any different option of point? If you take point A, what is the unknown you have? F and B, right? If this doesn't it become easier because you have 2 equations, 2 unknown? You can solve that one first and then use this one to get another one. So my suggestion is before you start going straight into calculation, you have to have this idea first to see what is the strategy to make it easier. Because this one will be longer than this one. Because this one is just straight with 2 equations, 2 unknown. If this one, it's 3 equations, 3 unknown, right? The answer should be the same and correct, but in terms of exam, sometimes the time is important. Right? So do spend 1 minute to just see the option before you jump in. Right? It can be saving you a lot of time. This is just strategy for mathematical calculations. The static bar is here, right? Free body diagram, and then you just apply. Any question? Right? Alright, so if we go to so basically they have fx, fy, and moment about A also, the same point there. And if you calculate, you get that value there. This one is straightforward because there's no 2 possibility. right? Straight away just what force before it moves, right? It doesn't have any tipping or tipping, right? Any question? Alright, what else? Okay, take a look at this question and give the answer. What is given is one is the block is 10 Newton, the weight. What is the magnitude of the friction force between the block and the space? So what is the friction? What is given is 10 Newton. Us is given force. So what is the friction? How many of you say 0? Ada? Tak nak nanti dia lain daripada lain. 1? Anyone? 2? Seorang? Dua orang? 3? Tadi macam ada? Tak jadi pula? None of them apa? Yang lain apa? Tak berani? Berani kena benar? Cik. Kan tak berani tu, tak tahu benar tak benar. What's the answer? Okay, for those who answer, okay, 0 tak ada one. For those who answer 3, why? How do you get 3? Oh, 10 times the number 3. Is that correct? Why not? Cannot? Okay, that is F max, right? And in this case, if you draw fluid diagram, this is 2 Newton, right? Can this be 3 Newton? No, right? That's not logical. It's not logical if you push it there. Itu dunia pelik lah tu. Dia tolak, friction dia tolak sini pula kan. So it can only go to this point, right? So in this case it's actually 2, right? So this is some common mistake where when you want to, because the remainder is there's several types of remainder, but when you try to, even though it's faham, tapi when you answer the question, normally you forget about that. You straight away apply some equation, right? So make sure you do not do things like that in the exam. Right? Okay, what about this one? This is the ladder. This is the wall and the floor. What is friction direction at B? A, B, C or D? Yang mana? A ke D? D. Like this. Everyone agree? I think this is how this is different than, because if you remember the first one before is something like this, right? This is the wall, and in this case, this is the wall where this is the ladder, right? So regardless of what is the ladder, what is the wall, the important thing is at this point it looks like this, right? So the friction is along the surface. When you zoom here, it's something like this, right? So the friction is in that direction. Even though this is the ladder and this is the wall, right? It's not what is the ladder, what is the wall, what will become the surface at that point. Okay, unfortunately it's already do we have time? So we have another slide, but this one is more interesting because we have shape like this, but unfortunately it's not in our syllabus. So our syllabus, what we have covered, we actually have covered all of the material that we need to cover in the day. But for whatever reason, they only give one example, the car. So they didn't give any example where slip or tip, etc. Which is, tak tahu lah dia suka pula feel ke apa. We have to cover. So next class we will cover some examples and some problems. Now, given that given that the material is already covered, so next we only have 2 classes left because I think next Wednesday is another holiday, right? Thursday. Sorry, next Tuesday. So our class have been hit by many holiday. But anyway, we have finished. So we have 2 class. One is this Thursday, one is next Thursday. We have 2 quiz left. One is this week is frame and machine or machine. Next week will be friction. So hopefully you can push the mark up. Of course, as I mentioned, because this is already quiz number 15 or 16, I think. 14. So we have 15 and 16, right? That's quite a lot. For those who have already, I already mentioned I will take only the best 8. So for those who already have 20 marks 8 quiz, they can sleep now. So because I will take the best 8. But for those who haven't, then there's 2 more chance to push up your quiz mark. And the material that I will cover is mainly revision and exercises. So for those who don't want to take quiz or don't want to do revision or etc., I will not force you to come because there's no new material, just new problem and exercise. So that's the mode.